Good to see you again. We're going to look at 3.03 intersection of graphs. And you're no stranger to intersection of graphs. That's basically any time two graph lines touch each other or cross. So our goals are explain how to find f of x equals g of x by graphing. Now, what does f of x equal g of x mean? That means solutions. So also solve the equation. Find the solution given two functions, again by graphing. Solve the equation of two functions by making a table of values. Now today you won't be asked to make a table, but you'll be asked to look at a table and use it to help answer these questions. So here we have a system of equations, pretty simple functions. And we learned yesterday we can solve this two different ways. Do you remember what they are? Algebraically and graphically. Two ways. So let's refresh our memories by doing that together. This will be a great time to pause and test yourself. So algebraically, we'll do that first over here. The first thing you want to do is set these functions equal to each other and solve for x. So since I have very simple x terms, there's no x squared, I'm going to actually solve this a little differently than we did last time. Last time we got everything on one side, set it equal to 0, and then we factor and set the factors equal to 0. But because we only have x to the power of 1 and then constants, I'm thinking it will be even easier to get my x's on one side and my constants on the other. So we're going to use some inverse operations to get our x terms together there. So these cancel out, equals 12. Already a very simple equation. We could just divide and we get x is 2. So already in 2 steps, we have our x value of the solution. So we're told there's only going to be one solution, and that makes sense if you look at this because you see a linear function with a positive slope and another linear with a negative slope. So we're going to have one point where they touch, and we want to find out exactly where that is. We know x is 2. How do we find out what y is? Well, we need to plug back into either function because remember, this point is on both lines. So it doesn't matter which one. I'm just going to pick the first one. So when x is 2, y is 8 minus 3, 5. So this is y. So our solution to this system is 2, 5. Perfect. We solved algebraically. Now let's do it graphically by looking at the functions above. First, f of x, y-intercept of -3, slope of 4, or 4 over 1, so rise 4, run 1. Rise 4, run 1, and rise 4, run 1 again. And I'll draw my best straight line through those points. There we go. All right, and that is f of x. Okay, g of x, y-intercept of 9, way up here. Okay. Slope of -2. So down 2, right 1, down 2, right 1. Bingo. Let's use a different color to really show what we have here. That is our solution to the system. 2, 5. That is exactly what we got before. So we're looking in good shape. We just want to finish graphing this. So down 2, right 1, down 2, right 1. I'd say that's enough points to get this put together. Here we go. Straight line through that point, and there it is. This is our g of x. Solution is the point where they cross. Well, why don't we get you prepared for the 3.03 quiz? Here's a little review of what it's all about. But for now, we're just going to take it one step at a time. We're going to focus on number one. Given a table, select all the solutions to f of x equals g of x. And that's exactly what we're going to do. Using the table of values, where does f of x equal g of x? Well, here's f of x, here's g of x. Where do you see those values being the same? 0, 0 right there, right? Where else? 4, 4 right here. But how do we answer this question? Well, we're being asked specifically, where are those values equal to each other? And they are when x is 2 and 6. So our answers are x equals 2 and x equals 6. And if you look at these functions, we didn't even need to do anything with them, did we? All the values were already found for us. Pretty nice, if I do say so myself. Okay, let's see how you do this one. Same idea, just a little more practice. So we see f of x and g of x again. We're looking for the same values. I see this row, same y values. Where else? Where else? Right here. So how do we answer this? Well, f of x is equal to g of x at the x value of -2 and +2. Simple, right? Okay, what's next? Well, numbers 2, 3, and 4 are very similar. You're going to be given two graphs, and you need to first pick the right graph. Decide, in other words, you're going to have the system of equations, and you need to match the graph with it. And if you're good at graphing, that'll be great. If you're not, the graphs are already there, so that helps. And then you need to identify the solutions. Okay, so let's practice that right now, right here. So we want to use the graph that shows the solutions to this. We'll get to that next. First, let's just match it. Okay, look at your graphs for a second. What's the same? The blue line, right? Is that the f of x or the g of x function? Well, that is a linear function, and that is a straight line. So that's our g of x, meaning that's not really going to help us get to the bottom of this, is it? But f of x will. How do we find a point if we have a function? Well, we've done this over and over and over again. Just pick an x value. It doesn't matter what it is as long as we can see it on our graphs. So pick an x value. I would prefer one that I can clearly see. Like right here, the y is a little iffy. Is that what? 0.8, 0.9, 0.75? I don't know exactly. So I'm going to look for a point I can clearly identify, like maybe right here. 2, 1. Okay, so let's plug in 2 and see what happens. When I plug in 2, look at that. I do get 1, 2, 1. On this graph, there is no point at 2, 1. So we know just from that simple substitution that graph B is the 1. Now, where are the solutions? How many are there? 2, right? 1 here and 1 there. This is 1, 2. And at -1, -2. Not too bad, right? So when you first look at this graph, you might be looking at the red lines and thinking, oh man, reciprocal power functions, I haven't seen that in a while. I don't remember. That's okay. We don't need to remember much about it, do we? What about this one? We have a quadratic and an absolute. Once again, a great way to start is by asking yourself, do one of these look the same on both? Because if we don't have to figure both out, why not save ourselves some time? Do this the smart way, not the hard way. Well, you should have noticed the blue line is the same on both graphs, and the blue line is our parabola, so that goes with g of x. So once again, we only need to work with our absolute value function. And let's look at our graph to find a point we can clearly see on the red line. So look at this red line. Let's see. I see right here, 4, 1. So if I plug in 4 and I get 1, that means it's graph A. Let's see. We get 8 minus 7. That's absolute value of 1, which is 1. We are on a roll today. So the point 4, 1, right there. Graph A is our guy. And the solutions right there. That one's a little tricky to see exactly what it is. And so is that one. So for this problem, I'm just going to estimate, okay? Normally you will not be asked to estimate, but this is at about, let's say 2.1 and up, let's say 2.7. And this one, we go left 1.1 about in the negative direction and up to about 9.3. Another way you could have identified the red line is by remembering that to find h, you set what's inside the absolute value equal to 0 and solve for x. Now, which way is easier? That's a personal preference, but I want to show you both so you have them both in your tool belt. Okay. I know one of the most common mistakes, people look at this and they just think, oh, dishonest h, -7, so h is 7 right there. That's only if x is by itself, but because x has the coefficient of 2, we need to work it out by setting the entire thing equal to 0. And I'll show you first off what not to do. If we said h is 7, if we didn't work this out, that would mean we moved horizontally 7, so in the positive direction, so right 7. Okay, is this right 7? Not at all, right? Actually, half of that, and you'll see why that makes sense. So if we take what's inside the absolute value, set equal to 0, and solve for x, you're going to find the vertex because the only transformation that was made here was a horizontal one. So we get 3.5, which is actually what h is. So we moved horizontally 3.5 units. Okay. And now it's time for your favorite, a word problem. And not just any word problem, one with two intersecting quadratic functions. So this is exactly what we've been doing. You have two functions, you're finding the solution. Only difference is they're both quadratic, and you're not given a graph, you're given a word problem. Here's the word problem. and you will see some decimals in the problem, but the process is still the same. Eli and Carl each throw a basketball straight up in the air at the same time. But Eli is standing on a deck, and the height of his ball in meters is given by this function. Notice it's a negative parabola, meaning here's the deck, here's Eli throwing the ball up. Okay? X is the number of seconds after the ball is released from his hand. So in other words, we could put in different amounts of seconds to find out exactly where the ball is at any time. And it makes sense that this is a negative parabola, right? Because it's upside down, like the motion of a ball being thrown into the air. Very useful for those type of situations. Carl is standing on the ground down here. And the height of his ball in meters is given by this function. Again, a negative parabola. That's going to go something like this. So once again, we're trying to find that key point where they touch. Okay? Again, x is the number of seconds. It's important that that's the same unit of measure. X is number of seconds. X is the number of seconds. So this is related. Okay? And there is a moment, like I said, when the basketballs are at the exact same height. And that's when that's that green dot. That's our solution. So what is the height? You're going to be asked to enter your answer rounded to the nearest tenth of a meter. Nearest tenth. Okay. Give it a try. Since we're not given a graph, how are we going to solve this? Think about that. We've done it today. Okay. Give it a moment. Give it a try right now, please. Okay. Here we go. We need to figure out when they equal each other, and we need to do it algebraically, right? Because we're not given a graph. So here we go. Let's work it out. Let's see how you did. I actually already did, so let's take a look. Set the functions equal to each other, and then we need to solve for x. What's really nice here, look at this, negatives, negatives. So if I add 2x squared to both sides, they go away. Add 3x to both sides, we get 8x. And then all we have left on the left then is 8x, and all we have left on the right is 3. We divide, we get a decimal. That is 4 in the tenths place. So we take this x value, we plug it into our original function, either one, and we square 0.4, multiply that with 2, multiply 5 times 0.4, combine those like terms, we get 1.68, round that to the nearest tenth, you get 1.7. So on a graph, remember, x is time, and they told us time here is in seconds, and y is height, and they told us that's in meters. So what was the question? What is its height? So our answer is 1.7 meters. And that's just about it for today. Just one final reminder, if you're ever unsure how to graph a function, make a table of values and substitute x values in to find the y values. That will give you the points.